Okay, so we've got our whole point slope outline, which is basically just dropping the slope, dropping the starting information. If we want to reverse that, which basically means if we want to graph it, what we ended up doing was identifying the slope and identifying the start value from the graph. What do we use first? What's the first thing we have to mark on the graph to graph it? The slope or the starting point? Yeah, so that should probably be the first thing we identify. So ID and graph the starting value from the equation.
It's an ID, like where it starts.
Identify, yep. ID, identify. So identify and graph the start value, and then from there, we used our slope or our common difference to just start plotting points, right? Yep. So use the slope to extend out the pattern or to plot the rest of the points. So use the slope to plot whatever the pattern is. Let's try a quick one together, just to make sure we've got the idea. And so we could put a reminder about that little opposites thing that happens, right? So here's one. So if I want to graph this, we're going to set up a little graph. The first thing we have to do is ID the start value. Yeah. And that's where we want to put a little comment that the x is going to be the opposite of whatever it is in the equation, right? And that has to do with the fact that this is getting us back to 0. So we're adding 1 to something to get back to 0. So you have to ask yourself, what am I adding 1 to that would put me at 0? Negative 1. It's going to be the opposite. So I'm going to put a little note that's just a reminder. It's going to be the opposite of what you see in the equation. Opposite of equation.
Okay, I guess that makes sense.
And then the y just is what it is, right? Opposite of equation. So whatever you see in the equation, when you pull it back out, it's going to be the opposite of what was written there.
Where does the x plus 1 come from?
That's our point slope equation. Our equation's already written and we're pulling the information back out of it to put it on a graph. So if we graph this, negative 1, 3 would be right here, right? I also want to use this as an excuse to talk about this. So this is telling me to go up 2/3 each time, right? So I could literally like up 2/3, up 2/3, but that's kind of weird to graph in thirds, right? Up 2/3. So I want to show you guys something. This would be if I just went up 2/3 each time, right? Using the slope or the common difference. It's in the equation, right there. Just got to pull it back out.
But how on the graph do you do it?
You're right. It gets weird because you have to estimate it, right?
Yeah, it wouldn't be accurate.
But watch. Here's a shortcut for fractions. Up 2 over 3. Oh, look. I land on the next whole number. We did some ready, set, go that reviewed that, right? Rise over run, exactly. So I could go up 2/3, up 2/3, up 2/3, or I could scale that up, and I'm still using the common difference. I'm just making bigger jumps with it. Going up 2/3 at a time is basically telling me for every 2 full squares I go up, I'm going to go over 3 full squares. And that's a lot easier to graph than fractions.